Okay, today we'll be looking at the encoder version 1.2. This is the Grove module from SeeedStudio. So there's 4 pins. So the SIG A goes to the yellow pin, SIG B goes to the white, VCC to red, GND to black. This will be the hardware connection to the board. This is the base shield. So on the left we have the yellow. So yellow is SIG A to pin 4, SIG B to pin 5, and on the right side will be SIG A pin 2, SIG B pin 3. Okay, let's step through the code. So at the top we have the definition for the pins. Then we declare some variables. So volatile will be for the interrupt service routine. So we'll be using interrupt version for one of the encoders, and for the other we'll be using processing within the loop. So in the setup portion, we'll be declaring the pin modes. We'll be reading, these will be the initial values, and then we'll be attaching the interrupt to SIG A. And this will be triggered whenever SIG A goes low, and this is the function that gets run whenever the SIG A goes low. In the loop, we have a serial printout for debugging and information, and whenever we have an encoder flag, we'll process it and then reset the flag to 0. For the other encoder to process within the loop, we will read the value and then we'll print it out. So encoder 2 will be on the right side here. This is the value of SIG A and SIG B. And when there's a change in the value, we will do the processing. So the steady state value is 1 for SIG A and SIG B. So whenever the SIG B goes low, then we'll do the processing. Then when SIG A, depending on its value of SIG A, we will know whether the turn was clockwise or anti-clockwise. So let's give this a try. I will turn the encoder 2 clockwise. Then you see the SIG B value changes to 0. So whenever I do a clockwise, it turns to 0. Then SIG A will stay at 1. When I turn it anti-clockwise, SIG B will go low and SIG A will change to 0. So in this way, we can detect whether the turn was clockwise or anti-clockwise. So that's what this code section is about. So whenever SIG A is 1, then we know it's a clockwise rotation, else it is anti-clockwise. Then encoder 2 value, this is a variable that we will store to keep a running value. So whenever we do a clockwise rotation, we add 1, and the anti-clockwise rotation will decrease by 1. So that's the encoder 2 value. So this is one way to test and debug your code. So whenever there's a change, then you pause it for a while so that you can see the output. So once the code is ready, you can decrease this value to let it have a faster response. So in this case, there's less delay, so you can see the value is more responsive. So this clockwise, you see the value increasing, and anti-clockwise, the value will decrease. So that's the processing using the loop. Okay, let's go to the other way, the interrupt way. I'll be changing to the other encoder. So in the setup loop, in the setup portion, we will attach the interrupt. So this ISR encoder 1 function will get run whenever SIG A becomes low. So the function is here. So whenever there's a change to low, and then this code will process. So the idea is the same. Whenever the SIG A and SIG B is the same, it determines this will be a clockwise rotation. So I add 1 to the value, else I will decrease by 1. So you can see in the serial output, encoder value 1, encoder 1 value, it will increase when I do a clockwise rotation and decrease when I do anti-clockwise rotation. So this will be the code to detect encoder changes clockwise or anti-clockwise rotation, and then maintaining a variable to store the value.